So when we talk about momentum, it is denoted by a small letter P. It is give you an idea about the amount of motion contained by an object. So when we are talking about the motion of an object, there are two factors that play a very important role, and that is nothing but the momentum is all about. So P is the product of mass times velocity. This is given in your data booklet also in the same way. So P is nothing but, or you can say momentum is the product of mass times velocity. And we already know that the mass should be in kilograms and velocity should be in meter per second. So you can easily identify the unit of momentum will be kg meter per second. And as velocity is a vector quantity, so the momentum is also a vector quantity. And the direction of momentum will be the direction of velocity. So in whatever the direction the velocity is there, in the same direction the momentum will be there. Now this is the basic idea of momentum. Now if we relate this back to the Newton's second law, so if I linking with Newton's second law that we have covered previously, we know that the F net or the net force acting on an object is nothing but mass times acceleration. So now when we are calculating F net, so this is when the mass is constant, right? This formula is
Yeah.
applicable when the mass is not changing. But if I say that, what if my mass is changing? Or in other words, F net is according to momentum. F net is defined as the rate of change of momentum, delta P over delta T. So the net force is equal to the rate of change of momentum. Rate of change of momentum. Now, momentum depends on the two factor we just discussed, that is the mass and the velocity. So if the mass changes, momentum changes. If the velocity changes, the momentum changes. So that is how you can say that. So F net is equals to delta P over delta T, and there are two factors in order to apply the net force. One based on the change in mass, one the change in velocity. So when the mass is changing, the net force or the average force can be written as delta m over delta t times velocity. Now, in this case, we apply if velocity is constant or if velocity is not changing, or you can say velocity is constant. So my mass is changing, but my velocity is constant, then I will use this way. And another way is F net or average force is equals to mass is constant, velocity is changing with respect, and velocity over time is nothing but mass times acceleration. And that is why we use this formula when mass is constant. So this is quite easy and more popularly used, but sometimes in your exam, in your IB, they may change the mass with respect to time. So the questions like a bucket full of water is leaking. So per second, some mass is coming out. So the momentum is changing. So if we needs to continue with same velocity, how much force is acting on the object? Or in other word, mass can be added as well. So a vehicle is moving and there is a continuously mass being added, or the water is added to the container, and it needs to move with constant velocity, you need to apply a force. So such type of questions are very common. We will try to use some of them. But let us start with the basic question first, and then we will see if we can apply that. Okay, yeah, try this question. Read the question carefully. As I mentioned, velocity is a vector quantity, so please, I would suggest you to draw a rough diagram first so that it is quite clear what you need to do. It is asking you for the change in momentum, and that too only the magnitude. Okay, so the absolute value of the change in momentum, how much it will be. Give it a try. Okay, so in this question, a body of mass 4 kg is moving horizontally. So it's a better habit to make a rough diagram. So let us say this is my ball and this is my vertical wall on the side. So it is moving with 8 meter per second. So I consider this direction as positive, the opposite as negative. So it bounces with this, and when it is returning back, it is having a speed of 3 meter per second. What is the magnitude? So change in momentum is always final momentum minus initial momentum, and we need to find out the magnitude only. So I take the absolute value. So mv minus mu. That would be my answer. So m is 4, v is minus 3, minus of why minus 3, because it is moving in this direction and this direction is taken as negative because it's a vector quantity. And mass is 4, initial is 8. So once you solve this change in momentum, you will get 4 times 3 is negative 12 and negative 32. So that will be negative 44. Absolute value will be 44 and the unit will be kg meter per second. And if they ask you instead of magnitude, if they ask you simply the find out the change in momentum. So you will say minus 44 kg meter per second, where negative direction shows it towards left, or you can say 44 kg meter per second towards left, because that's your final momentum. Momentum is in that direction. Okay, now this question, read it carefully, try to apply what we have done above, give it a try. Wait, yeah, give this question a try. So basically, in this question, you can say the mass is changing. So whenever the mass is changing, think in that terms that we discussed. So F net will be delta m over delta t times V. Now V is constant, so we will use this formula. So delta m over delta t in the question is already given 0.2 kilogram per second. Now many students ask me, sir, how we will think that we need to apply this? So look at the units in the question, that will give you a hint. Kilogram per second. That means that delta m over delta t is given. This is kilogram, this is second. So kg per second. Sometimes they may give you in grams also. So that you need to connect. And it is at constant speed. So constant speed means this formula, because we use this when mass is changing and speed is constant. So this is a hint that you can think that you need to use this formula. So value is given 0.2, velocity is 3.5. You just multiply, you will get 0.7 Newton. So the net force you need to apply in order to have a constant speed is 0.7 Newton. I hope you have understood this. Okay. Give it a try for this question, read it carefully. So for A part, if I need to solve, it's quite easy. Change in momentum, as I mentioned, mv minus mu. So mass is 0.5. You can read the graph. This is the initial velocity and this is the final. So final is minus of 2 minus of 0.5 times 4. So when you solve this question, you will get minus 1 minus 2. Absolute value will be 3 kg meter per second. So that's the answer for your part A. Most of you might have got this correct. Now for the B part, you have to pay attention one thing. The ball is stayed in the contact with the floor with 0.15 second. It means this ball is in contact with 0.51 second. And what is the average force does the ball exert on the floor? So average force that the ball exert on the floor will be the weight of the ball in the downward plus the force due to collision with the ground. Now, force due to collision with the ground, mg we already know mass is 0.5 into g you will do. Now, force of collision we need to use the change in momentum over time, the Newton's second law in terms of momentum. So, change in momentum we already find out 3. Time for that change in contact is given 0.15. So, this you will get 20 Newton and mg 0.5 into 9.8. So F average now will be this plus 3 divided by 0.15. So once you solve this, you will get something around 24.9 Newton. That is your average force, or you simply say 25 Newton.